A 10 liter of an incompressible liquid exerts a force of 20 newtons at the Earth's surface. At the same volume, what force would the liquid exert on the moon, given that the gravitational acceleration is 1.67 meters per second squared on the moon? All right, so for part A, they said the force of the Earth is 20 newtons. The formula for force is equal mass times acceleration. In this case, acceleration is just the gravitational force of the Earth. Okay. We also know, so these units, what I like to do is look at the units to make my own formula. So this is kilograms per meters per second squared, which is just a Newton. And then if I do volume, gravity, density, this is kilograms meter cube, volume, which is just a meter cube. And then this is meters per second squared. So you can see that these units line up, right? And it's still a Newton. Okay, so this is my formula. We know for problem A that for the force on the moon and on the Earth, that the volume didn't change because that's what they stated. And we know the density doesn't change. It's only a function of pressure and temperature. It's not a function of the gravitational force. So we know density doesn't change. So we know mass doesn't change. So we know that the density, volume, or mass does not change. So if I rearrange this problem and solve for density and volume, this is equal to force of Earth over gravitation of Earth. I could make an equal formula for the moon. Force on moon over gravitational moon, right? I can equal these two together. Right? I can solve for the force of the moon. And then all I have to do is plug in my numbers. Gravitational force of the moon is 1.67 meters per second squared. And then we should know this, that the gravitational force of the Earth is 9.81 meters per second squared, right? So these units cancel out, and we're left with newtons. And if you put this in a calculator, you would get 3.4 newtons. Okay. Now for part B. What force would 2.3 liters of this liquid exert on the surface of the moon? And then the same thing, the gravitational acceleration on the surface of the moon is 1.67 meters per second squared. So in this case, we have a change in volume, but we know the change in density on the Earth and on the moon is going to stay the same. Again, it's only a function of pressure and temperature. It's not a function of the gravitational force. So we're going to do something similar to what we did here, except we're going to solve for mass. Let me show you. Actually, no, we're going to solve for the density. Okay, so we have this same formula as we had before, and this is of Earth. This is also of Earth. So if we solve for density, okay, and we get that. And again, we can do a similar problem for the moon. So I should put E here because those volumes are different, right? And then right? These are equal, so we can equal these two equations together. Right? And then I can solve for F of m, which is the force on the moon. Okay. Okay. And then the force on the Earth, what was it, 20 newtons? The volume on the moon is 2.3 liters. The gravitational force on the moon, 1.67. The volume on the Earth, what was that, 10 liters? Yep, 10 liters. And then 9.81 meters per second squared for the Earth. And then you can see my units cancel out. And I'm left with newtons. And if I plug this into my calculator, I get 0.78, 0.78 newtons. And that's it.